In this section, we'll take a look at the Configuring and Monitoring High Availability objective of the JNCIS Service Provider exam. We'll examine how you configure and how you monitor BFD. For more detailed coverage of this objective and more, please check out the JUNOS Intermediate Routing course. In this video, we're going to take a look at configuring BFD, and we're going to configure BFD on the XR1 router and the R1 router for the BGP session that's running between them. So what problem are we trying to solve with BFD? Well, we're trying to speed up the detection process of network failures, so a link failure or the remote router failure. If the link failure or the remote router failure resulted in our physical interface dropping, we would immediately detect that failure. But otherwise, we have to rely on the hello packets that are integrated within routing protocols to detect that failure. And typically, we're looking at multiple tens of seconds of interval for these hello packets. And that means that we then have a multiplier on top of this hello interval. So we're potentially waiting over a minute sometimes to detect any failure if we're just relying on routing protocol hellos alone to be able to detect this failure. So this is where BFD comes in. BFD is a very simple protocol, and what we do is that we slave the liveness detection of routing protocols to BFD, and because BFD is a much more simple protocol than the standard hello messages that are being sent by a routing protocol, it means that we can send them at a much more aggressive interval. Because it's also a simple protocol, under certain circumstances, it also means that we can offload the sending and receiving of BFD packets from the routing engine to the line cards, which further means that we can scale this protocol further. It means that we can support very aggressive detection intervals, and it also means that we can support many thousands of sessions. So that's a quick overview of BFD theory. Let's now get into it and actually start configuring BFD for this BGP session. So we're on R1. Let's have a look at the current BGP session that we're going to configure. So it's this BGP session facing into XR1. And the key thing to note here is our keep alive interval is 30 seconds and our hold time is 90 seconds. So we're sending a keep alive every 30 seconds, and after 3 missed keep alives, a total of 90 seconds, we're going to declare this session dead and tear it down. And so we're going to react to any failure that's resulted in the other end stopping sending keep alives or our ability to receive those keep alives. And obviously a downtime of this 90 seconds is not suitable for a lot of scenarios in modern networks. So we're going to change the configuration of this BGP session to use BFD for liveness detection rather than relying on the sending of keep alives alone. So we're going to drop into configuration and we're going to configure the ebgp group. This is the configuration we've got at the moment. So we're configuring BFD liveness detection. Having a minimum interval of 500 milliseconds and a multiplier of 3. This means we're going to be sending BFD packets every 500 milliseconds, every half a second, and after 3 missed BFD packets, we're going to declare the session is dead. So let's commit the configuration, and let's do the same on XR1. And now we've committed that BFD configuration. So let's have a look at the BGP neighbor. You see we now have the BFD enabled flag listed in a show BGP neighbor output. This means that BFD is enabled for this session. And if we do a show BFD session, this is showing us the BFD session that we've configured. We've got the remote IP address, the session state is up, the associated interface. So we've got our transmit interval of 500 milliseconds, multiplier of 3, which means that we're going to detect failures in 1.5 seconds. And at the bottom here, you can see a summary of the number of packets a second we're generating for BFD. And we're looking at an average of 2 packets a second based on this session alone. And obviously, detecting this session failure in 1.5 seconds is significantly better than detecting that failure in 90 seconds. So this is why you might consider using BFD in conjunction with your standard routing protocols.